Welcome to This Explainer. Today, we're going to completely dismantle and rebuild everything you thought you knew about value in the digital age. Because look, most people see Bitcoin and they just think, oh, it's digital cash, or maybe just some speculative asset, right? But to truly grasp its revolutionary nature, we have to move way past those surface-level ideas. We really need to look at this profound four-part equation derived from the work of the researcher and author known as @DearGigi. It's money, plus time, plus energy, plus information. So over the next few minutes, we're going to explore exactly how these fundamental forces of nature and computing literally lock together.
Okay, let's dive right into this. Here's our roadmap for today. We'll build this equation piece by piece, starting with money as pure information, then moving on to the problem of time, the decentralized clock, energy and proof of work, and finally, making digital information real.
But before we get into the complex mechanics of cryptography and thermodynamics, we need to ask a shockingly simple question. Why do we actually use money? I want you to challenge your fundamental assumptions right out of the gate here. We are so used to swiping cards and handing over paper bills that we kind of forget money is a relatively recent invention in human history. It was designed to solve a very specific problem, the coincidence of wants. You know, if I have apples and you have shoes, but I don't want your shoes, well, we can't trade. Money steps in as that universal middleman. At its core, it's really just a way to remember who owes what to whom across an entire society.
And that brings us to Section 1, Money as Pure Information, where we start moving beyond the physical realm entirely.
Now, what's really fascinating here is what happens when you strip away the gold, the silver, and the paper. When you take away that physical medium, what's left? Well, you're left with a ledger. Money is simply a system of communication. It's a messaging system for keeping score. Think about the ancient rice stones on the island of Yap. These were massive limestone discs, literally too heavy to move. When a trade happened, the stone stayed exactly where it was. The islanders just updated their collective memory of who owned it. The stone wasn't really the money. The shared information was the money.
Let's compare these two concepts directly. Physical currency obviously requires physical transfer and storage. You have to physically hand a $20 bill to a barista. It's bound by the laws of physics and geography. But information-based money, that's purely digital ledgers and data communication. When you send money through an app on your phone, there's no physical object traveling through the air to the bank. A database simply updates. Your account goes down by 20, the coffee shop's account goes up by 20. Modern value is simply information moving across networks. But, and this is a big but, this entirely digital reality creates a terrifying vulnerability.
Let's see how this builds into our next variable in Section 2, the problem of time, and specifically, how we go about ordering that information.
So here is the massive complication. If money is purely digital information, how do we stop people from simply copying it? Think about it. If you have a digital photograph or an MP3 file, you can copy and paste it a million times. But if you do that with a digital dollar, you destroy the entire economy. It's a classic issue known as the double spend problem. In the traditional world, a bank acts as the central authority. They look at the timestamp and say, okay, you spent this dollar at 1 p.m., so you absolutely cannot spend it again at 1:05 p.m. But how on earth do you agree on the timeline of events without that central bank acting as the referee?
This quote from our source material absolutely hits the nail on the head. Time is crucial because without a universally agreed-upon sequence of events, decentralized information cannot be trusted. In a decentralized network where literally anyone can participate from anywhere on Earth, whose watch do we actually trust? If my computer says a transaction happened at 2 p.m. and your computer says it happened at 2:01 p.m., who wins? Without a shared, undeniable sequence of time, a decentralized network is going to collapse into utter chaos. Time is that missing essential ingredient.
Which leads us directly to Section 3, the decentralized clock, ticking in the digital realm.
And as brilliantly illustrates the mechanical ticking of the network, acting as its own self-contained decentralized clock. Step 1. Transactions are broadcasted to the network, kind of like shouting into a crowded room. Step 2. That data is grouped into what we call blocks. And Step 3. These blocks are linked sequentially to form an unbreakable timeline. You can really think of each block as a tick of the clock. Tick, block 1. Talk, block 2. By mathematically chaining these blocks together one after another, the network creates a definitive before and after. It doesn't actually care about hours or minutes on a human clock. It only cares about the sequence of blocks. It creates its own internal time.
And that brings us to our fourth section, energy and proof of work. Powering the clock. So the absolutely crucial point here is this incredibly powerful equation: energy equals security. You see, this digital clock cannot just run on software alone. If it did, any hacker could just write a few lines of code, spin up a fake clock, and rewrite history to say they never spent their money. To stop that from happening, you need a physical anchor. You have to demand intense physical energy to anchor this digital timekeeping system directly to the real world.
This is the sheer genius of proof of work, and it essentially has 4 core functions. First, it bridges physical energy into the digital space. Computers or miners have to burn real electricity and perform massive thermodynamic work to find the next block. Second, this secures the decentralized clock. Third, it validates the timestamps. And fourth, and honestly most importantly, it makes rewriting history impossibly costly. Because every single block requires massive physical energy to create, if a bad actor wanted to rewind the clock and change a past transaction, they would have to outcompute and outburn the energy of the entire rest of the global network combined. It literally enforces the arrow of time through the laws of physics.
And that brings us to our climax, Section 5, Making Digital Information Real. This is the final synthesis of our explainer today.
To truly understand what's happening here, we need to look at this concept called reification. Now, I know it sounds like a super complex philosophical term, but it really just means making an abstract concept physically real and immutable. Think about taking the abstract concept of a melody playing in a musician's head and pressing it into the physical grooves of a vinyl record. That is reification. By fusing digital information with physical energy and a strict arrow of time, the network gives mere data the unchangeable permanence of a physical object. You can't easily change a mountain, and you absolutely cannot change this ledger.
So we return to the completed equation. Bitcoin equals money plus time plus energy plus information. It's not just an app, guys. It's not just a digital coin. It's a revolutionary network where pure information is ordered by an unbreakable decentralized clock, which is in turn powered and secured by the undeniable laws of thermodynamics and physical energy. These 4 fundamental forces lock together to create a system of value that operates completely independently of any human authority.
Which leaves us with this final, really provocative thought to take away from this explainer. What is the future of money now that it's inextricably tied to fundamental physics? If value is no longer just paper printed by governments, but is instead pure information anchored by energy and time, well, how does that change the way we interact, trade, and build our society over the next century? It's a profound shift in human history, and understanding this equation is the very first step. Thank you so much for joining me, and keep questioning everything you know.